Hey guys, welcome back everybody. So we have covered the spanning tree protocol. We have seen the Ether channel, and one of the guy has asked me the one question about the disadvantage of the Ether channel. That's a very good question was there. So I gave you the explanation of that day, right? Traffic polarization, one of the biggest issue, right? Because sometimes what happened, because of the bad design, switch one we have switch to take example, and so this is the 0/0 and this is the 0/1 link, right? So normally this is also a 10 meg and this is also 10 meg. So due to the bad design, what happened? So whatever the users are sitting behind the switch one and whatever the users sitting behind the switch two, right? Due to the just a bad design, what happened? I did my aggregation, right? I did my Ether channel over there, but my all traffic is going by the, or not all traffic, I can say the 90% traffic is going by the upper link and the 10% traffic is going by the bottom link, right? So we can call as a one link is overutilized, right? In a simple terminology, right? Another link is underutilized. So this is the one of the biggest, right, challenge that you may face, right, in the Ether channel. So how you can avoid it? So you see, mostly what happened, the recommendation by the Cisco is what you need to have a good design, right? So before deploying the Ether channel, right? So you need to see whatever the IP addresses you have, because eventually, we have seen the load balancing mechanism in the Ether channel, right? So based on the load balancing mechanism, right? The switches is gonna select the one of the port, right? So yeah, you need to have a better good design in your network. And another thing is that good design of IP address as well as, right? Good design of not troubleshooting, load balancing algorithm you need to put, right? And even if you have like you have done each and everything, right, and still you are facing the issue, right? So then you need to deal with the self configuration, right? I know this is a little bit high level, yeah, but you can achieve this thing, right? So biggest issue is the traffic polarization is the biggest challenge that you may face with the help of Ether channel, right? So we have seen that, and also there's another disadvantage also. So one of the major is this one, right? That's a very high level one, but yeah, if somebody will ask you, you can explain in this way, right? So if somebody will ask you, what is traffic polarization? Traffic polarization is simple is that what one link is gonna utilize 100% or maybe the 90%, another link is not properly utilized. So in that way, it's a totally wastage of bandwidth of this particular link, right? Okay, that's fun things that done of the Ether channel. Okay, quick question to all of you guys. Everyone, right? So a PC needs IP addresses, right? And PC needs the MAC address as well as, right? So for example, the IP address I can put this guy's a 1.1.1.1, and the MAC address I can put this guy's a. Okay. So in the another PC we have this guy's IP addresses we have, it's a 1.1.2, and the MAC address I can call it this guy's a B right now. So in this case, what happened? The PC1 can communicate with the PC2. There is no issue, right? Because we have IP addresses, we have a MAC addresses over there, right? Same way, this is the one like a PC to PC communication, we can call it, right? But take example, if you have a multiple PC, maybe you have a 10 PC or 5 PC, then you need to take help of the switch, right? Either you can take a help of the switch, or either you can connect with the hub as well, right? So, but nowadays we cannot say that hub is not being used by the companies. We are still using the hub in the production network, right? Because switch is a little bit costly in some, in not every company, in some scenario where the budget has some issue, right? You can use the hub as well, or you can go with the what we call uh, unmanaged switch, right? So within the LAN network, you can help provide the connection with the help of switch. We can provide the IP address to the each and every PC, right? And if you have a WAN communication, or we can say that if you have a two different broadcast communication, two different subnet, for example, you have a 1.0.0/8 and we have a 2.0.0/8, right? And we have some Fox over there, right? So they belongs to this network and they belongs to this network, right? And if you want to provide the communication between these two guys, then eventually you need a router over there, right? That's we have seen in the basic part, right? Now, question to you guys. Take example, I have a 5 PC or maybe the 10 PC, right? In the 5 PC or 10 PC, what you can do that you can simply go on the route, or you can simply go on the PC side and you can define the IP addresses. So whatever the IP addresses that you're going to define, that's you're going to define as a manual way. So for example, you have a 10 PC, right? So the PC number one, I can call as a 1.1.1/8, like this way. PC number two, we have right? On the PC number 2, I can say that, hey, I have IP address will be, come on, I have IP address is 1.1.2/8. PC3, we have IP address will be 1.1.1.3/8, right? And so on, right? You can go with the PC number 10. Now we have a what 1.1.1.10 IP address will be /8 over there, right? So in this way, you can define the IP addresses, right? That's all the ways what this all the ways of manual configuration of the IP addresses. That's you're defining the IP addresses on the species the manual way. Manual way means what? Try to understand. Manual way means you have to network engineer. This is the network engineer. This network engineer has to go on the PC number 1 and say that, hey, one thing I like to define the IP address is 1.1.1. This network engineer has to go on the PC number 2 and say that, hey, I like to define the IP address 1.1.2. And this network engineer has to go on the PC number 3 and say that, hey, I need to give the IP address 1.1.3/8 over there. So in a manual configuration, what happened? You have to go PC to PC and define the IP addresses. I'm not denying it. It's a bad, it's a good, right? If you have a small network, if you have 5 PC, 10 PC, or maybe the 15 PC, you can define the manual IP addresses. But if you have a large number of PC, for example, you have 100 plus PC, or maybe the 200 plus PC, or maybe the 500 plus PC, if you have, in that way, how can you define the manual process over there? For example, take example, this is the Saurav, right? And Saurav is a network engineer. And I say the Saurav, hey, Saurav, listen, there's a 500 PC. You need to up this PC right now, right away. Saurav said, hey, I don't know how to up this PC because I have to first define the IP addresses. Once I'm going to define the IP address, then he can access the internet. So Saurabh doesn't know. Saurabh just need to go to the PC to PC and define the IP addresses. So maybe Saurabh will take the at least 3 to 4 days to define the IP address on the 500 PC. Okay, that's a manual way. Take example, if this guy, right, did the configuration of the PC, did the configuration of the IP address on the PC side, all the way of the manual configuration, right? What is the main issue with the manual configuration? Can anyone tell me what do you think? What is the problem with the manual configuration?
First of all, time, and then secondly, the IP address is hard-coded.
Perfect. Oh, no, second point. Oh, can you repeat that one?
The IP address is hard-coded, meaning that's what is fixed. So if there are some other changes on the network and
Amazing. Hard-coded, right? Right. So the first is the time, second is the hard-coded, right? Third thing, you need to maintain the database stable. You need to maintain the database stable in the sense of what? You need to know that, okay, 1.1.1, I already gave to the PC number 1. Easy to make a mistake. Perfect example. That's how the automation comes in the picture, right? So PC1 has a give the IP address 1.1.1, PC2 give the IP address 1.1.2. You need to make this database, okay, I have given the 1.1 to the PC number 1 and 1.1 to the PC number 2 and 1.1.3 to the PC number 3. You need to maintain the database table. Because you cannot put the same IP addresses, right? I cannot, as for example, the PC 1.1 I already allocated. What happens if I'm going to allocate this guy same as a 1.1.1? Then duplication will happen. Right? Duplication will happen. So you need to maintain the database table. What is the fourth issue we have? Try to understand, normally when you configure the IP addresses, right, what you have to configure, you need to configure the IP address 1.1.1.1, then you need to configure the subnet mask information. Guys, IP addresses, then subnet mask information. Then what? Guys, just give me a moment. Someone is at my door right now. Okay, sorry. So you need to give the IP addresses, you need to give the subnet mask information. Then what?
I think you have to.
gateway and
Okay.
the DNS information and all that.
Okay, hold on. Understand the concept. Now, picture comes over there. If somebody will ask you, hey, I need to provide the communication between the PC to PC. Do you need to give the default gateway?
No, no,
Do you need to give the DNS?
no.
No. So try to understand, if you just have a LAN communication, right? I don't need to define anything. Just for the LAN, this thing is enough, man.
Right, right.
Right? Understand the concept right now. Just for the LAN, these two things are enough. But take example, if you have a WAN communication, then you need to define the IP addresses. You need to define the submit mask information and correct submit mask information, because if you missed a single bit, if you miss a single bit in the submit mask information, then what happened? It will be a part of a different broadcast domain. For example, if I want to see this guy's IP address 101.3 and I just put the /9 over there, then what happened? This guy and this guy should not communicate, because this guy is in a different broadcast domain and this guy is a different broadcast domain, right? So the submit mask information is very, very important. Third part is what? If you have WAN communication, DNS. Fourth, default gateway. Do you know, you need to type all these things on a PC side. Now, is it possible? Can I do the manual configuration? Even on the 10 PC, it's very hard. And you need to remember each and everything, right? By mistakenly, if you did the mistake, then eventually what happened, your PC cannot communicate with the internet. Now, troubleshoot comes in the picture. What people are doing the troubleshooting? I'll tell you. When the troubleshoot comes in the picture, your PC is not communicating with the internet, right? Or maybe some server is not accessible by the PC. Normally, what people start doing, they're starting the troubleshooting from the router side. Do we have it out? My interface is up or not? Or maybe server issue. First, always start with the troubleshoot from the physical layer. Check from your cable side. Check from the cable side, then go in the data link layer, check the MAC address information, all those switches information, and then you can go with the layer 3 side. Don't start your troubleshooting from the layer 3 always. Start with the physical layer. So maintaining all this part, maintaining all this information, right? It's very tough, man. If I'm doing the manual configuration of the IP address on the PC side, it's very tough to maintain all this information. It's a time-consuming, hard-coded, and database maintained. It's a very tough task. And by mistakenly, manual means what? Manual means a network engineer. Always comes in the picture. When you have a manual, it doesn't matter. You're doing the manual IP address configuration or you're doing the static route. The static route is known as the manual configuration, right? You are gonna make a mistake over there, 100%. According to the Cisco tag, right? 70%, right? Tag cases are coming just because of the manual configuration. According to this, I'm not saying that's or any my assumption, it's given in the book even. I'll show you in the documents as well. When I'm going to teach you this DWAN, the theory part, I'll show you that. 70% tag cases are coming just because of the manual configuration. So to avoid this problem, right, what happened? We came with the solutions called the DHCP. DHCP allow you understand the meaning first of all. D for dynamic, H for host, C for configuration, and P for protocol. The first of all, he's saying, hey, I'm going to dynamically configure the host. What configuration I'm going to do that? I'm going to do the configuration of the IP address with the help of protocol. Which protocol I'm going to use it? I'm going to use the bootp protocol over there. I'll come to the point what is bootp, don't worry about that. So with the help of DHCP, dynamically, I'm going to assign the IP address to the host. Again, this host, it doesn't mean that only the PC. This host doesn't mean only the servers over there. You can even assign the directly IP address to the router as well. So DHCP is not only dedicated for the PC side. You can also configure the dynamically IP address to the router as well. So with the help of DHCP protocol, what I can do that I'm going to dynamically configure the IP address to the network. Do I need to maintain any kind of database table for the DHCP? Manually, no, I don't need to maintain anything. How much time it will take? Just a matter of 1 second, man. Just a matter of 1 to 2 seconds. Whenever your PC comes up, right? Automatically what happened, this PC will get the IP address from the DHCP server. Whenever this PC comes up, automatically what happened, they will make a request, hey, I need the IP address, server will give the IP address to this guy. Whenever this PC comes up, he will request to the server, hey, I need the IP address, hey, this server will give the IP address to this PC. What Saurabh will do now, this network engineer, he's gonna watch the Netflix now. This guy only comes in the picture, okay, when something is gonna bad. So that's a beauty part of the DHCP protocol. DHCP allow you to configure the IP address dynamically. Right? Now, in DHCP, what happened normally? Take example, we have this is the router. So I'm going to configure this router as a DHCP server, but in the production network, what happened? You have a dedicated server, right, for the DHCP. But if I talk about the Cisco exam perspective, in a Cisco exam, what happened? You have a router and you need to convert this router as a DHCP server. But in the production, it's little different. Okay. So in a Cisco exams, you always have a router. On that router, you have a DHCP configuration. So take example, this is my one of the router. That's I'm going to configure eventually as a DHCP server. Then after that, we have a switch over there, right? Right. And then after that, we have some PCs, right? So take example, we have some PC1, PC number 2, and PC number 3, right? And I'm just going to provide the connectivity with this link to this guy, and this guy. So we have a PC number 1, that's this guy. I'm not going to define any IP addresses to this guy. I just need to configure the router 1 as a DHCP server, switch 1. This is my link. We have a 0/1. This my link is a 0/2, and this my link is a 0/3. Right? This is the link. We have a 0/4. Now what happened? I just need to go on this DHCP server. What I can do that? Simply, I will create the first command. I will do the IP. IP again, this first keyword, the IP is going to represent that we are doing the configuration for the IPv4. Then the second keyword that you need to put, because we are doing the DHCP configuration, you need to put the keyword DHCP. And then you need to create the one logical pool. A pool is what? It's like a container. You need to create a logical pool. It's pool like its container, right? A swimming pool, you can also assume that. A swimming pool is a collection of water. Okay, so I'm just going to contain the one container we have over there. And this guy name is a pool. So on a single router, you can have a multiple pool. To identify that particular pool, you can give the name for this guy. I'll just put the name is a CCI. This is the pool that I'm going to create. And in this pool, right, what is present, I'm going to put the IP addresses over there. So in this pool, I'm going to put the IP addresses like a 192.168.1.0/24. It means that in this pool, how many IP addresses we have now? We have IP address range from the 192.168.1.1 to 192.168.1.254. So this is the range of the pool this is the range of the IP addresses that I'm going to put in the pool. So the first of all, what we have to do that we need to create the pool over there. And the pool name is what? CCI. Once you enter this command, automatically what happened? You will move to the DHCP configuration box. And then I can define the range of the IP address that I'm going to allocate in the pool. So I said that 192.168.1.0. Some platform on some IOs, right, you need to define the subnet mask information, right? And in some IOs, right, what you can do that, you can simply put the network 192.168.1.0/24. So some IOs does support the concise way to define the subnet mask information. We can call as a CIDR value, right? And some IOs does support the subnet mask information. So if I talk about the Cisco packet, so that's a basic purpose. So in the Cisco packet, so you cannot put this command. If you have a newer Cisco packet, I'm not pretty sure that you may put the command, but in the older, you don't have an ability to do that. But in GNS3 and EBNG, you can put the both command, right? That's all. This is the enough configuration to provide the LAN communication. That's enough configuration. So basically the pool that you have created over there, right? So whenever the PC will make a request, whenever the PC will on, so what happened? So they will make a request to the router, right? Hey, I need IP addresses. A router will take the one IP address from the pool, they will assign to this guy. Same way when another, for example, now he will get the IP address is 192.168.1.1 and automatically the submit mask information. Same way the another PC say, hey, I also want to communicate with this guy, so I need also IP address. So he will ask to the server, hey, I need IP addresses. He will take the IP address from the pool and he will assign to this guy. Now he will have IP address is 191.1.2/24. A basic funda. So let's do the basic practical. Let's understand the basic terminology of the DHCP. Then I'll come to the deep dive of this thing. So I already have a Cisco packet tracer. So I'll take the 290 data. I have a switch over here. All good. And I have some few PCs, right? PC 1, 0, 1, 2, 3. That's fine. 3 is enough. Remove the 0 right now. PC 1, PC 3, and PC 2. So this DHCP configuration that we are doing right now only for the LAN, not for the LAN. All done. All good. Done. I'm so sorry. Okay, so the IP address on this interface that I'm going to allocate, that should be the 191.168.100, right? Of course, the subnet that I'm going to use for the pool is what? CCI, the pool name, and the range we have a /24. So let's assign the basic configuration on the router side. No. Enable config terminal host name are what? Fine. And interface 0/0, right? We have a gig interface, right? Gig 0/0 we have. And IP address, I can define this double 192.168.1.1/24. And then. So my this interface has IP address now. This interface is up right now. Next part is what? We need to define the DHCP configuration. The first configuration I can define over there IP. The first keyword IP means IPv4. DHCP, then we need to define the pool. Pool name, you can define anything. I just enter the DHCP config mode now. And here I can tell this guy, hey, listen. That's done. So this is the pool now that I have created. The same one. Right? Now have a look. So I just need to go on the PC side and desktop IP configuration. I'm not doing the static configuration. I'm just click on the DHCP now and have a look. I got the IP address. So if you see, I don't have a default gateway set because I haven't assigned the default gateway over there. I just define the IP address 1.1 and submit mask /24. Same way, if you go to the PC number 2 right now, desktop IP configuration and DHCP, I got the IP address. Don't worry right now how those things is working in the background, we'll discuss. I'm just giving the overview right now, that's nothing else. And same thing, if you go to the PC3 right now, desktop and IP configuration, right? Click on the DHCP and I got the IP address 103 now. Perfect, right? So now if you want to provide the communication, right? If I want to ping from the PC3, this guy has the IP addresses right now 101. This guy's IP address is 102. This guy's IP address is 103 right now. So now if I want to send a traffic from the PC3, right, to the PC2 or PC1, I can send a traffic. 102, it's working. So for the LAN communication, guys, right? For LAN communication, let me big size a little bit. what you can do that simply. First, the basic part, you need to go on the router interface 0/0. Depend on the which interface you have. I say the 1.100. Any IP address you can take it, no shutdown. And I say the IP DHCP pool name is CCI. You can have a multiple pool as well. To identify the pool, you have to define the name of that pool. And done. Sorry. But for this guy, what's the default gateway they are going to use right now? They're going to use the default gateway as a 0.0.0 because I haven't set for the default gateway, right? So for example, if you want to do the WAN configuration, what you can do that, you need to go on the router side, same, go in the pool again, right? I just moved to the DHCP config mode. And now here you can define the default route. That's a command to define the default gateway, right? So the default router means what? So whatever the IP addresses that I'm going to define over here, whatever the IP addresses I'm going to define over here, that will become a default gateway for this PC. So of course, if this PC wants to go to the internet, they will go through this guy, right? If this PC wants to, because this is the one single home right now. This is the one broadcast domain, right? So this will be the gate to go in the different broadcast domain. So if just take example, we have a internet on this side, right? So what happened? This interface is the gate for all these PCs. So whatever the IP address of this particular interface will become the default gateway. So I just say that 191.168.100. That's done. You want to define the DNS server? I can define it 8.8.8. Let me check, does it support the backup one? No, it doesn't support. In GNS3, it will support it. So you do have ability, you can define the primary DNS server and secondary DNS server. You do have ability, right? So Cisco packet doesn't support it, also in the GNS3. And now you can see that. Let's go back in this PC1 again and put the static keyword. And again, DHCP. Now you have a default gateway and DNS. Same way, if you go to the PC number 2 now, static, go back to the DHCP. Done. Same thing if you go to the PC3 right now. Static and DHCP. Now all we have a communication. So now I can provide the WAN communication. So now you are done with this part. After that, the routing comes in the picture. So for this LAN communication is successful, everything is fine right now. So even now, if you're not able to ping it, right? Take example, if this PC is not able to communicate with the internet, then you may have an issue with maybe the DNS has not completed the complete information. The DNS server doesn't have a proper information. Maybe you have a filtering applied on the switch side. Maybe have a ACL applied on the interface or router side. Maybe you don't have a route for that particular network, but you don't have any issue from the DHCP configuration side. So for the WAN, a basic configuration is what? Same way, right? Instead of exit as the default router and DNS server 8.8.8. That's all. Now, how those things are working in the background, understand the concept. So I'll take a one PC and one server right now. So this is the PC, right? And this is one of the server right now we have. Of course, you will have a switch in between. So I'm not taking the switch right now because, diagram will become lengthy then. Right? Okay. So I have a configuration of the DHCP right now on this guy. So let me put this configuration. Okay. Now, so right now the PC1 and spread out on one. So we have this interface as a 0/0. So normally when this PC will boot up, right? When you start this PC, so it start looking for the IP addresses. It start looking for what? Start looking for the IP addresses. So if this PC doesn't have an IP address, then what he will do that? He will make a request. He will make a request. Which request he will make it? He will start looking for the DHCP server. He will start looking for the DHCP server, right? Because you haven't assigned the IP addresses statically, then what happened? He will make a request for what? Start looking for the DHCP server. The first packet the PC will send, that's called as a discover packet. As the name suggests, that discover means what? I'm gonna looking for what? Now I'm gonna looking for the server. In this discover packet, try to understand what information you will have. You will have a source MAC information. You will have a destination MAC information. You will have a type field. Okay, leave the type field right now. Okay. What will be the IPv4 type field, guys? Anyone can help me out? What is the type field for the IPv4? And VLAN. Anyone? Okay, someone sent a message. Perfect. So 0x0800, that's for the IPv4, right? So you have a type field as well. Then you have a source IP address. Then you have a destination IP address. And then you have a UDP protocol. Let's make a protocol. Let's leave the protocol right now. We'll discuss that thing and port number. And then after that, we have a DHCP. So the first packet that he's going to send, we have a source IP as well. We have a destination IP. Then we have a port number, right? Source port number, I can make it. And destination port number. And then we have a discover packet. The first information that you have in the source MAC will be what? A. For example, as I'm assuming that's the MAC address of the species is A. The MAC address of the species is what? Is A. Right? So you'll first put the MAC address is A. Destination MAC, I really have no idea. So I'll put the broadcasting because I'm looking for the server. That's the meaning of broadcast MAC address because I have no idea where the server is located. So I will make a broadcasting in my LAN network. Then type field will of course 0x0880. That's going to represent that I need to forward the packet to the IP. Layer 3, we can call it. This is a 2-byte field, right? In the Ethernet header. That's help you to identify, should I forward the packet to the layer 3 or layer 2? If you have a VLAN, then I need to forward the packet to the VLAN only, 0x8100. That's for the 80.1p protocol, right? And then what happened? You have a source IP. Do I have IP address on this PC right now? No, I don't have. So I'll put the 0.0.0.0. Destination IP, I'll put the broadcasting again. A global broadcast address. Source port number 67. Destination port number 68. Sorry. Source will be 68. Destination will be 67. And then we have a Discord packet. In the Discord packet, you are looking for you have some information that's called as the magic cookies. Multiple information will be there. Magic cookies. Magic cookies is nothing but it's just extra information, right? About client and server. Just extra info, nothing else. So now the PC1 is going to send this packet to whom? Router. What router will do that? Router is the server, right? They have a DHCP configuration. Router will, this is the first packet is called the discover packet, right? The opcode, right? The opcode for this guy is what? Operation code, we can call it. For this guy will be what? It should be the request packet because I'm requesting it to the DHCP server. Packet type is what? Discover packet. Now the router one will receive this packet. What a router will do that? He has a DHCP configuration. He will give the reply, right? That's a opcode. So either your opcode will be the request packet, right? Or either your opcode will be the reply. So request has a value is 1, reply has a value is 2. He will give the offer. Opcode is what? Reply. Normally, offer means what? I'm telling you something, you can use this IP address. So in the offer packet, what happened? Actually, your IP addresses are present. So when the server is giving the offer packet to the PC, what he will do that? He will again create the packet. Right? You have a packet, source MAC, distance MAC, type field, source IP, destination IP, source port number, destination port number, and magic cookies. So source MAC, destination MAC, type, source IP, destination IP, source port number, destination port number, and offer packet. Source MAC could be the MAC address of this interface. Take example, I'll put the MAC address of this interface is X, right? Destination MAC, broadcasting, type, source IP, my this interface IP, which is the 1 or 100. Right? Destination IP, again broadcasting, source port number, destination 1, and again magic cookies. In this magic cookies, you will have a actual IP address. So when the router 1 is give the offer packet to the PC, he will say, hey, now you can use this IP address 192.168.1.1. That's my offer packet that's sent by the router 1 to the PC. Let's look this part only. Then I'll come to the next packet. So let me open my GNS3. This again, this is a Cisco behavior, guys. On a Windows, your reply packet will be the unicast packet. Okay. On Cisco, what happened? Your reply packet is a broadcast packet. Things are changed according to the platform. Remember, I told new batch. Okay, maybe I'll tell you in the routing. Okay, don't worry. So I'll call this guy as IP DHCP. I think so. I already have a maybe lab. So DHCP. Okay, that's fine. 2 pieces there. PC3 and PC2, right? And this is the 1.100 IP addresses, this interface IP addresses. Let me check the putty size, what I have. That's fine, 18 is good. Okay, why it's taking so long? Yeah, it's can come. Oh. Okay, so let's start with router 1, which is my server right now. So I'll change the host name for this guy. Let me check, do we have IP address or not? This configuration. I don't have. So I'll change the host name. And guys, please pay attention. So I'm going to show you some debug message. I already explained you the meaning of debug in the few back classes, right? So debug means what? You can check the background information, right? What's happening in the router side. So I'll say the host name is what? DHCP server. Right? The first configuration interface 0/0 IP address will be 100/8 nodes are down. Now debug DHCP and DHCP server. And I say the events, that's very important for me right now. And packet as well. So the first command that I'm going to put over there is what? IP DHCP, right? Pool. What pool name? CCI. Network. You can put the /24 as well. You do have ability, right? You can define the /in and then or ABCD network mask. Either you can define the CIDR value or either you can define the service masking function. And now you can see that. So this output that I'm getting right now because of the debug command. So which debug I have enabled that? Debug IP DHCP server events. That's going to help you to show the how many pools that you have created on the router. So it will show you the how the pool is created. So you can see that the DHCP, I'm going to add the IP address 191.1.1 to the 1.254 to the which pool? CCI. So this is the range of the IP address that I'm allocating in the pool. This is the range of the IP address that I'm allocating in the pool right now. And we have a pool name is this guy. Now what? As that, let me define the IP DHCP, sorry, default router as well to just give the IP addresses of the default gateway and DNS server. I can define the 8.8.8.8. I do have ability to define the secondary server as well as. So the first one is the primary one and second was the secondary one. Now what? I'm done. Let's go to the PC. Before I'm on a PC, let me enable the Wireshark. And I'll also write on the host MAC addresses of the each interfaces. So let me show interface 0/0 include BIA. And the MAC address of this interface is C201. And let me write on the MAC address of the each PC as well. So show IP interface brief. I don't have an IP address. So interface 0/0 include BIA. I think so this one PC2. For the PC3 as well. All done. And here we go. All done. So now let's do the Wireshark. So what I can do on the router side, how you can assign the IP address dynamically on the router side. So if you see, first of all, I'll show you the manual configuration interface 0/0. What you can do that you just need to go on the first, let's convert this router as a PC. So I'll say that what? No IP routing. Remember, this is the command to disable the routing behavior on the router side. And I say the interface 0/0 IP address is what? Is 1. Maybe 1, that's fine. And no shutdown. So if you see, this is the way that you can configure the manual configuration of the IP address on the router side. If you put the command, it will show you the method is manual. If you have a DHCP, then method, it will show the DHCP over there. Right? Even if you see the do show IP interface 0/0. Setup command, right? Now what I can do that, I'll just remove the IP address from this PC side, right? And I want to get the IP address from the DHCP. So what do you have to do that? You need to enable the DHCP behavior on this router side. So I first put the command IP address, right? DHCP. That's done. I'm saying that I need to allocate the IP address on this particular interface, right? Through the DHCP protocol. And I'm done. And now let's go to the capture. I can see that Discord packet we have, right? So let me filter out. So the protocol, you can see that the protocol field, we have a DHCP, right? We have a destination IP addresses. We have a source IP addresses. And these are just a time, right, over there. And these are the length of the packet, and we have information of the packet types. So I'll just filter out the packet right now, DHCP over there, so that we will not see these are information. So this Wireshark will help you in production as well. And if you're planning for the CCI exam, it definitely help you. So the first packet, if you see, right, that I've created a source MAC address, of course. I'll put the packet capture over here as well. That's this one. So let me remove this guy. Let me remove this guy as well. And this one as well. So you can see that the first information we have that's sent by the PC number 2, right? Ethernet header we have C202. That's a MAC address. So you can see the C202 MAC address of the PC2. The destination MAC is what? It's a broadcast MAC address, FFF, right? 48-bit. Okay. And the type field, you can see the 0x0800, right? That's a IPv4 representation, right, on the Ethernet header. It will be changed according to the behavior or according to the topology or networking that you have done. IPv4, if you see that in the layer 3, you have a source IP address 0.0.0 because I have no idea, right? I have no idea of IP addresses, so I will put the 0.0. Destination is a 255.255.255. That's a destination IP address. And the most interesting concept on the layer 2, if you see that, what information you have, guys, please pay attention. It will help you to explain the, OSI model at the higher level. On the layer 2, we have a type field, that's a 2-byte field. That's going to tell you that we need to forward the packet to the layer 3 or not. If you have a VLAN or if you have an ARP, then you need to forward the packet at the layer 2. There will be no IP header information. Because of the Ethernet is saying that you need to forward the packet to the IPv4. That's why we have a layer 3 information, IPv4, right? On a layer 3, right, you have an information about what? Layer 4, protocol field. On a layer 2, you have an information about the layer 3. On a layer 3, you have an information about the layer 4, the protocol field. So UDP has a protocol number is 17. So of course, we have a source IP 000 and destination IP, of course, broadcast. Next part is what? According to the layer 3, he's saying that I need to forward packet to the home UDP, and UDP works on a which layer? Transport layer. So I need to go for the transport layer now. So you have a transport layer UDP, source port number 68, that's for the client, and destination is 67, right? And now we have a dynamic host configuration protocol, that's my Discord packet, right? If you go to the Discord packet now, right, the first message type is what? It's a boot request. Now let's go back to the 90s. Okay, just give me 5 minutes. I'll show you something. Let me go you 90s time. What is the meaning of boot over there? So this keyword, you can see that, right? Boot request. I'm just going to explain you what is the meaning of boot over there. It's so before the DHCP protocol, right? Before the DHCP protocol, right? We have something called is what? RARP. Reverse Address Resolution Protocol. We have something called as a RARP. So before the DHCP, we have a RARP protocol. Reverse ARP Resolution Protocol. It's a reverse. If you just break down this word right now, it's normal ARP that we have seen, right? So in the normal ARP, what happened? We were requesting for the MAC addresses. Remember, we were requesting for the MAC addresses. But in the reverse ARP, what happened? Instead of requesting for the MAC address, now I'm going to request for what? The IP. Understand the concept. In the ARP, normally what we did, we were requesting for the MAC information. It's a reverse. Now I'm requesting for the what? IP. So in backend, right? In back in 90s, 80s time, what happened before the DHCP, we have a RARP protocol. So we have one RARP server, try to understand. And this RARP server was providing the IP address to the all the PCs. So take example, we have PCs over there, we have PCs over there, and there are the PCs over there. So this PC, if this PC wants to get the IP addresses, right? So they will request to the RARP server will give the IP address to this PC. Same way, he will request to the RARP server, I need IP address, he will give the IP address to this PC. He will request to the IP address, he will get the IP addresses, right? Problem with RARP is what? RARP was a layer 2 protocol. Okay, RARP is a layer 2 protocol. Rarely, very rarely, you will see the interview seen in the interview this kind of things. RARP. I'm just explaining you so that your concept will be clear for the DHCP. So RARP is a pure layer 2 protocol. Pure layer 2 means what? For each broadcast domain, you need to have a one RARP server. Take example, you have a VLAN number 10, you have VLAN number 20, you have VLAN number 30, you have VLAN number 40, you have VLAN number 50. For each broadcast domain, you need to have a one RARP server. For each broadcast domain, you need to have a one RARP server, each one. Because it's a layer 2. So take example, assume it. If you have a 50 plus site in your network, and I'm just talking about each side, we just have a one broadcast domain. If you have a 50 plus site, then how many servers you needed? 50. I need a one server in the Delhi location. I need a one server in the Mumbai location. I need another server in the Patna. I need another server in the Jaipur. So the RARP, the biggest issue is the layer 2 protocol. So it's only allocate the IP address within the broadcast domain. It cannot go beyond the broadcast domain. That's an issue with the RARP protocol. RARP was defined in the 1984, right? The configuration was simply devised to the diskless workstation with the suitable for the IP addresses. It was a data link layer. It required, I cannot, let me use this one because I already have something in my Epic pen right now. Understand this one. RARP was in 1984, right? It works on the data link layer. It required that servers be present on an individual network. Then what happened? This was the problem. To avoid this problem, what happened? RARP was superseded by the BOOTP protocol. And this is how the BOOTP comes in the picture, guys, over there. The boot request. So after the RARP, what happened? We came with the concept is called the BOOTP protocol. BOOTP was amazing because BOOTP is saying that, hey, it was introduced in the 1985, right? This introduced the concept of relay agent. It means that I'll explain you the meaning of this word. Don't worry about that. The meaning of relay agent. Simple, I'll tell you. The meaning of relay agent means what? It allow you, the BOOTP allow you, right, to provide the dynamically IP address to the different broadcast domain as well. It means that in RARP case, what happened if you have a 10 broadcast domain, then you need to have a 10 server. But in the BOOTP, what happened if you have a 10 broadcast domain, you just need to have a one server. Can you see the cost saving right now? Huge. It's a huge cost saving, right? To avoid, but BOOTP has its own problem. BOOTP has its own problem. So in a BOOTP, the problem was what? So you have an issue with the timing. For how many time we can allocate the IP address to the PC, like a release timing. This timing problems we have in the BOOTP protocol. Not only the timing right now, whatever the new technologies are coming, they are not supported by the BOOTP, and that's why the protocol comes in the picture is called the DHCP in 1993. But the problem with the DHCP is what? DHCP still use the bootp concept. So start with the 1984, then 1985, and then 1993. And just for your knowledge, in 1993, the DHCP came right at the same time that your concept is called the classless routing. The classless concept also comes in the 1993. That's why you have a this keyword over here, the bootp, the boot request. So now this guy what has sent the first packet to the Discord packet to the server right now. If you see the port number, this hardware type is Ethernet. It means that we are doing the DHCP right now on the Ethernet media. If you are doing on the serial link, this value will be changed. This value has its own meaning right now. We'll see that the meaning of this value. It's a major important, this value, 1. This is the hex format. The decimal format of this guy will be 1 over there. If you have a different technology, you will have a different values over there. The hardware address length is just 6 byte. Okay, most of things are very important. I'll help you in the different video as well for this guy. Whatever each things we have explained this thing. Most important part is what you have to look for this guy right now. We have a client MAC address in the Discord packet. And some cookies that you can see that right now. Magic cookies. Magic cookies means what? Extra information. Extra information about what? Client and server. So right now the client is sending the Discord packet. So I have a client information, for example, host name. So if I'm going to change the host name on this guy, if I'm going to make this guy the host name is a R3 or maybe the R4, the host name will be changed over here. Client identifier, the option 61 MAC address. So we have a discussion about the options field. Don't worry about that. Okay. Then what happened? Once the server will receive this Discord packet, now the server will give the reply packet. And the reply, if you see that, that's my offer. Reply will be the opcode. Right? Same one, Ethernet MAC address is the C201. That's the MAC address of the router 1. Broadcast MAC address, IPv4, IP version 100. That's my IP address of this interface and the broadcast. Same protocol number UDP 17. And then we have a port number. So now the port number is changed. Can you see that? So previously, when the client was sending the packet, the port number is 68. When the server is sending the packet, port number is 67. And now this is my reply packet. Same hardware address length is MAC address 6 byte. Transaction ID is just a session ID, nothing more. So for this guy, we have a 1 session. For this guy, we will have another session. So for this guy, there will be a different transaction ID. Or for this guy, there will be a different transaction ID. The boot flag is just going to tell you, right? Is it a unicast packet or broadcast packet? So right now it's a broadcast packet. That's why it's broadcasting over there. But in different scenario, I'll show you that in the relay agent concept, it will be unicast over there. And then after that, you can see that the server is giving the, hey, this is the IP address that I'm allocating to you. To whom? The MAC address of C202. So the IP address that server is allocating to this guy is 101 to the client, this guy. And how does the server will get to know that this is the MAC address of this person? Because in the Discord packet, you have sent this MAC address. In Discord packet, you have sent the MAC address. So now the server is giving the IP address to this client. So when now the server, right, try to understand, when the server will give the offer packet, right, discover and offer has done. Now the R2 will again ask, by sending the request packet, hey, whatever the IP address that you have given me, right, the 192.168.1.1, I want to take this IP address. So he's requesting, could you please allocate me this IP address? Now the, again, client, let me draw the packet over here. because I don't have a space over there. So this is my discover packet adjustment right on over there. Discover, this is my offer. And then we have a, I'll draw over here. So this is my request packet that is sent by the again PC, source MAC, distance MAC, type field, source IP, distance IP, then what? Source port number, distance input, and then we have a packet. So source MAC will be again C202. Or I have just put the A over there, that's fine. So I'll just put the A over there. I don't have a space to write all those things. FFF 0x0800. Then we have our source IP again 000. Right, again in the request packet, still I'm using the 0.0 because I haven't confirmed it from the PC router side. So I'm requesting it, allocate me. So in that case, I'll put the 00, destination 255, source, destination, and my request packet. In the request packet, I'll put the same IP addresses. That in offer packet, I have received it. So if you open the request packet, that's sent by the PC again. You can see that Ethernet C202, that's a PC broadcast type protocol 00 destination broadcast protocol 17 and the UDP source port 6867. Now we have a request. What he's sending to this guy. Same boot P Ethernet, nothing is different, right? Transaction ID is same, right? Flags are same. Now we have a what? This is my client MAC address. And now if you go down, you will see that the most interesting is what? Now this router 2, this PC has got to know that about the server. He put the server identifier is a 191.61.100 and the requested IP address is what? 1.1. That you have already sent me in the, so this was the offer packet that's sent by the home router to the client. In this offer packet, they put the 1.1 IP address. The same IP address you can see in the request packet. He's requesting that I am good to go with this IP addresses. Now allocate me. So once this guy, the server will receive the request packet, what he will do that now? He will give the acknowledgement. Now, acknowledgement is what? Does it reliable? DHCP? We have seen that TCP protocol is a reliable protocol, right? And UDP is not a reliable protocol. See, UDP is not reliable, but DHCP makes itself as a reliability. How? With the help of acknowledgement. So in the acknowledgement, what happening now? Same one. Source MAC will be what? Maybe I'll take the example X of the router. Distance is FFF again, 0x0800. Source IP 000. Distance IP 255 is still. Then what happens? 67, 68, and then we have acknowledgement. And now if you see the acknowledgement, same one. Source MAC, destination broadcast type. Source IP is 1.100. That's a router 1. Broadcasting, UDP. Source port number 67. That's mean that it's sending by the server. And here we have acknowledgement. Same boot reply. So the message type either could be the boot request and boot reply. Request will be the 1 and reply will be the 2. This is the op code value, operation code value. Same hardware address length means what? 6 byte. 6 byte means what? He's talking with the MAC address. Transaction ID will be same for all the packet flags. And now if you see the go down, I will look at this IP. Sorry, this one now. This one. That's a server identifier, server IP address. This is the client one. Don't worry about that. All this cookies field that you can see that right now, option 54, 53, 51. At the end of the day, you have a clear picture of all the cookies right now. But focus on the important part that we have discussing right now, the client IP address. So basically what happened, if you see that, it's doing the DORA process. This process is known as the DORA process. First, discover packet. Second is what? Offer packet. Third is what? Request packet. And fourth is acknowledgement packet. Same way, if you have a look, if this PC is going to request for the IP, go on the router 3 right now. I said no shutdown, first of all, IP address DHCP. One or two, and if you see the interface IP address now, DHCP previously it was manual, right? Address determined by the DHCP. So previously, if you see that, it was something else set up by the command that you done manually. Now, set up by the DHCP. What is the difference between switches and what is the difference? You asking this question right now? I'm still confused. Huawei, can you help me out with like? I still like you. We have discussed this thing. Like in the first day of the class, what are the different switches? The layer 2 and router the layer 3. If you want to connect if you want to provide the connection within the LAN network, you can go with the switches. If you want to connect with the WAN network, you can go with the router. Even if you can go with the layer 3 switch as well, right? MAC address on the switch, IP address on the router. Yeah. Like, do you have any question regarding this DHCP behavior on this router and switches behavior you're asking?
Oh, for now, you can go on. When we are confused, we will let you know.
I think so. Can you speak so that I can understand your questions, right? Because your question is not valid according to this class, right? Like a DHCP classes. I think I already explained that difference between the switches and router in the like we have did the almost 3 to 4 days of class on the switches and router only the difference. Okay, so this is the how you can define the addresses through the DHCP protocol on the PC side, guys. The most interesting concept that you have to look over there is what? The transaction ID concept. So if you see that, this guy, so I'm just removing all the packet structure right now. So you can see the most interesting is what? I have a one session over there. This session is a totally individual session because this PC got the IP address is 1.3, right? So we have a dedicated session for this guy. So 1.2. So we have a dedicated session for this guy. Same way, then what happened? This guy has made a different session. Oh, this is again, it's a logical connection, guys. It's a logical connection. This guy has got the IP address is 1.3. This is the logical connection. Or you can say that a session.
Okay.
To identify this logical connection into session, we need to put some identifier over there. Because how does this router will identify this is a different session and this is a different session? And that's why the transaction ID concept comes in the picture. So you can see that, right? So this was this one, this one, this one, and this one is for this guy. This one. This one, this one, this one, and this one is for this guy. So we have a dedicated session for the each client requested the IP addresses. This session ID is a 32-bit number. Okay, you don't need to remember each and everything. You just need to understand the concept of the DORA process, that's all. So how they will ask you the question in the interview. So in the interview, they will ask you the question, hey, can you please help me out? Like, what is the source IP address when the PC will send? And what is the source destination IP address in the packet capture? What is the source port number and what is the destination port number? So this kind of logical question you will get in the interview. Understood? Anyone has a question in the DORA process, guys?
Not at the moment.
Okay, great. So the next part is what? So that's all about the basic DHCP behavior. Let's take example. What we can do now. Okay, so understand this. Okay. So understand this topology right now. So one server we have, so you can see that we have two different locations first of all. Okay, let me remove this guy. Okay, so one location we have in the Kabul. Okay, that has a subnet. We are going to use the 191.1.0/24. Another sub branch we have in India, LAN of India, LAN of Kabul, and we have a different subnet. We have 2.0/24. So this is the India router that we have IP address is 2.100 on this interface. We have this is the WAN connection we have. You can see that the between the router 1 and router 2, we are going to use the subnet is 12.0/24. This is the India router. This is the Kabul router. And in the itself in the Kabul, what happened? We have a DHCP server. DHCP server is not present in the India location. DHCP server is present in the Kabul location. That's the beauty of the BootP protocol. It is not possible in the RARP, right? So BootP has a advantage. What you can have only one server. It doesn't matter which location is this. The client will get the IP addresses, right? So if the client is sitting in the India, they can get the IP address from the DHCP server, which is located in the Kabul location. So let me start with the basic configuration of the basic IP addresses part. Let's see whatever the IP is configured or not. We will remove this guy. Okay. That's all the done. Router 1, if you see that. Oh, R3, I just can remove it. Have multiple times. I don't have R1. R1, I can remove it. Yeah. So if you see on the router 1 right now, the router 1 is that's my DHCP server. Let me change the host name first of all. Host name will be DHCP server Kabul. Right. Okay. Yeah. So do show IP interface brief. If you see, I don't have any IP addresses allocated on this particular interface. So you need to assign the manual IP address on this guy. Interface 0/01. IP address again allocate this guy 12.1/24. No shutdown. Same way I can allocate the IP address on this particular interface is manually interface 0/0. IP address is 100/24. No shutdown. Done. Now what we have to do that basic configuration of the DHCP, I can just copy and paste it, right? So that's fine, this IP. So one, understand this concept. So we have a two different subnet, right? So for the two different subnet, what we have to do that we need to configure the two different pool. On the router one, that's my DHCP server, Kabul, right? So IP DHCP pool, I can allocate this guy name is a Kabul. So this is for the Kabul user. So whatever the users are sitting in the Kabul, they can get the IP address from this pool. So network is what? Is 1.0/24. And default route I can set it. I can give this guy as a default route as a 100, right? So the IP address of this interface, right, will become the default gateway for this PC. So that's done for this guy. Same way, I need to do the another pool over there. So I'll just copy and paste it, right? So I just need to change the name and the IP network over there, India. And we have a 2.0. You can see that this network is running the 2.0 subnet, right? /24. So same, you have to get this range of the pool on the router one side because this is the DHCP server. Then what? I need to assign the gateway IP address. So for this PC, the gateway will be what? This 2.100. That's done. So this basic part we have done. Let's configure on the router one. Before I'm going to do that, I'm just going to enable the debug IP DHCP server events. And let's put the command. So I have a two DHCP pool right now. One is for the Kabul. That's I'm going to look at this range of the IP address. Another pool we have for the India. Same way I have just done. Let me configure this in the notepad. So on the router one, what we have done, we just did the configuration of the IP addresses 12.1/24 and no shutdown interface 0/0. This 0/1, 0/0. We have a IP addresses. This is gonna go with the 100 and no shutdown. That's all. On the router number two, that's we have on the other side. On this guy, we need to give the basic IP address configuration interface 0/0. IP address will be 0.2. No shutdown. Interface 0/1. IP address will be what? 2.100/24. Done. Let's do the same thing on the router number two right now. If you see on the router two, I don't have any configuration. I'll just start the configuration with the 0/0. All done. Interface 0/1. Let's go with the 2.100. And here we go. Done now. Anything else? No. So let's go to the router one right now. And you can see that I already give the pool over there. So you are configuring an IP pool on the two different interface. No, Nia. I haven't configured it. Can you see that in my notepad? I just configured the DHCP, two DHCP pool, one for the Kabul and one for the India, because my DHCP server is located over here in the Kabul location. So I need to configure this thing on the router one. On the router two, I just configure the normal IP address, nothing else. Understood?
Hello,
Yes,
sir.
Sir. Oh, sorry.
No.
Sir, when you configure in R1,
Mhm.
suppose sir, in I want to communication in India, in R1 we create sir two pool name.
So
We do not.
understand this is the user sitting in the India, right? I don't have a
Okay.
DHCP server in the India location.
Okay.
My DHCP server in the Kabul location. So I need to configure this range of the pool on the Kabul server.
Okay. Means Kabul network engineer will configure
Exactly.
DHCP.
The Kabul network engineer is going to do
Okay.
that, not the India network
Okay.
engineer.
Okay, okay,
Indian,
clear, sir.
Indian network engineer is just gonna inform to the Kabul engineer, hey, this is the subnet that we are using. Please configure this thing on the Kabul side.
Okay, 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 clear, sir. Thank you, sir.
Okay, understood.
So now understand, if you go to the router 3, that's my client. And if I'm gonna say that, hey, listen, I want some IP addresses. So what he can do, the interface 0/0, no shutdown. And as the IP address DHCP. That's all. And he will get the IP address from this pool. Kabul 1.0. Got it? But how are the router 4 right now? Can I get the IP addresses? If you see, if I'm just going to put the interface 0/0, right? No shutdown, IP address DHCP. I won't. This PC4 will not get the IP addresses. The reason is that, understand the concept first of all. When this guy, he's sending the Discover packet, if you're going to capture this particular link, I'll show you that. If you see, the PC4 is sending the Discover packet, right? See, there is no issue at this point because the router 3, or we can say the PC3, can request a Discover packet to the router 1. Router 1 is the DHCP server, he will get the reply to this guy. But over here, if you see that, the PC4 is sending the Discover packet to the router 2. Can you see that? But router 2 is not responding it. Understand the reason. Do you know the reason is what? Router break the broadcast domain, right? Router break the broadcast domain. We have a separate broadcast domain over there. This link is a separate broadcast domain. This link is a separate broadcast domain. So when he's requesting for the broadcast packet, what happened? This broadcast packet comes over here only. It will never go beyond this guy. Router break the broadcast domain. By default, on the router side, the broadcast capability is disabled even. If you check on the router 2 right now, if you put the command do show IP interface 0/0, what you can find it? I cannot send the broadcast packet. That's a behavior of the router. So if the router cannot, because he's sending the broadcast packet, right? Router cannot send the broadcast packet to the router 1. So what we have to do that? I need to convert this broadcast packet to the unicast. The packet that R4 is sending right now, how? Understand this concept. Assume that the MAC address of this guy is the X, destination is the FFF, source IP is what 0.0.0.0.0, destination is what 255.255.255, right? I need to convert this broadcast packet what into the unicast because router cannot forward the broadcast packet. And to convert the unicast, right? To convert the unicast, the DHCP comes with the feature is known as a DHCP relay agent. You need to go on this particular interface, right? And tell them, hey, because right now the router 4 is sending the broadcast packet is looking for the server. And router 2 is saying that, hey, I don't know where the server is located. Router 4 is sending the broadcast packet to the router 2 and say, hey, I'm looking for the server, the DHCP server. Router 2 is saying that, hey, I have no idea where the DHCP server is located. So you need to go under this interface and say that, hey, listen, IP address, IP helper address, the first command, and you need to define the IP address of the server. Helper means what? The first keyword is helper is what? This helper keyword is gonna enable the relay agent on the router interface. So now whenever the broadcast packet comes over here on this particular interface, it will hit to this particular interface. On this particular interface, I have configured the helper is what? The relay agent, this guy. So this is the DHCP server IP address. So when the router 2 will receive the broadcast packet, what he will do that? He will convert into the unicast. Guys, please pay attention on the packet now. So in this packet, what happened? The source port number is what? 68 and 67, right? The client and server. Now understand the packet, what happened? We have a same The MAC address now will be the 01 MAC address. This MAC also will be changed over here. This MAC will be changed according to the interface by interface, because layer 2 will be keep changing. Focus on the IP part. IP will be the 2.100 now. And destination will be what? 12.1. So when the router 2 is converting this broadcast packet into the unicast, right, what happened? It will become a relay agent, right? Relay agent is what? It's a part of the DHCP server. So if it is a DHCP server, then what happened? Your port number also will be changed 67 to the 67, not the 68 now. Am I done? Have a look. If I'm going to give this command, let's put the enter over here. And let's capture this particular link. Let's go back to the R4 again. And I'm going to remove this command and go back and re-enable this command again. See, Discord packet is coming over there. Can you see that? But do you see the offer packet now? No. Understand the concept again. So this broadcast packet comes over here. There is a problem. The router cannot follow the broadcast packet. So we did the DHCP release and configure on this particular interface. On this particular interface, we told that, hey, you need to send the packet to whom? DHCP server. And he's sending that. Can you see that? This is the capture link between this line. This is the capture of this link between. You can see that I have a Discord packet. So now I'm able to send the Discord packet to the router number 1 right now. And if you open this packet, right, what you will find that this is the pure unicast packet. MAC is unicast. Right? IP is unicast. Port number, if you see, 666, 6767. And DHCP, if you have a look, the flag, what is there over there? It's still saying the off. It should be off over there, man. It should be not on over there. It should be off over there. It's a unicast packet. But now router 1 is able to receive the offer Discord packet, but is not giving the offer packet. Do you know the reason? Because when the router 1 is trying to, right, when the router 1 is trying to send the reply packet to whom? 2.100, right? That's a source IP in this unicast packet, right? When he's trying to give the reply to the 2.100, he's looking the routing table. Hey, do I know about the 2.100? Sorry, 2.100. 1 minute. No. You can see that? I'm able to receive the Discord packet, but I'm not able to send the offer packet because I don't have a route for this guy. So the basic part, what you have to do on the router 1 side, you need to give the routing toward this guy. A basic static routing, I'm giving this. Next service to LR2. That's all. I know the routing. If you don't know, don't worry about that. When Monday we'll start the routing part. But I'm doing the basic configuration right now. Otherwise, I have to wait for the Monday. That's all. So now if you go to the PC4, you will get the IP. You can see that? Now it's giving the offer packet, request acknowledgement, and I'm getting the offer. So basic part, what you have to do that, guys, 2 things are very important when you configure the IP DHCP relation on the router 2 side, right? Under the interface, 0/1, I need to call the IP helper address The meaning of this command is what? Just gonna convert the broadcast packet into the unicast. The reason I need to convert the unicast, because router cannot forward the broadcast packet. That's a behavior of the router. Router break the broadcast domain. Exit. On the router one side, we need to give the static route, because if you don't give the routing, how does the router one will send the offer packet to the India?
Hello, sir.
Yep.
Sir, static route to configure only in Kabul
Router one, only on the router one.
router 1, not configure router 2.
क्यों कॉन्फ़िगर करना पड़ेगा? Router 2 से तो ये directly connected ना.
Okay.
Router for the router 2 is directly connected out, so no need to configure the routing over there.
IP helper address is running in R2, sir.
Yes, R2 this interface 0/1.
Only this command running, but all DHCP
All the DHCP
configure and
configs on the router one side.
okay,
The
sir,
reason I
clear,
need to
sir.
put this, the reason I need to put this command, because when the router 4 is sending the broadcast packet to router 2 on this particular interface, router 2 does not know how to forward this broadcast packet to the different broadcast domain. So we need to convert
Okay,
this packet in the unicast. And how the router allocate the IP from the particular pool when the two different
yes,
pools
sir.
are available. How the router
Okay, clear, sir.
how the router allocated IP from particular pool. What do you mean a particular pool?
Particular port, sir.
Nisar has a different to say. Hey Nisar, can you speak? I didn't understand your question. How the router allocate the IP from the particular pool? Two different ways we have to, right? Yeah, we can, right? This one you're talking what? This Discord packet that app sending by the router to right now? But how router allocate which PC should get the from? Oh, that's one you and I got your question now. Understood. So there's a field. I'll say that. Hold on. Okay. Man, what is that? There's one field, man. I'll show you that. Hold on. This one, 2.100. Because the pool that I have created on this router, if you see that, right? From this subnet over there. So when the router 2 will, when the router 1 will receive the packet, when the cable will receive the packet, right? Is looking at the DHCP relays and information, the IP address information. And he found that this IP address belonged to this subnet. And based on that, he's giving the IP address to from that pool, the India pool, not from the cable pool. Understood? Great. Anyone else has any questions, guys, regarding the DHCP? I'm not done with the DHCP. We have a more session. No? Okay, that's great then. So do this practice, okay, and I'll catch you tomorrow with the DHCP security part. That comes in the DHCP snooping, right? And few stuff for the DHCP as well. Is DHCP better than static? Of course, man. Is DHCP always better than static? Because is it possible? Can you configure the 100 plus PCI addresses? No, right? In a static way, if you're going to configure it, you will get the lots of issues, right? You have to maintain the database tables. You need to correct the configuration. You need to also make sure that this same IP address could not configure on the another site as well. So DHCP maintain all these things, right? So DHCP is a dynamic way. Of course, there will be no problem. If you do the static, always will be a problem. Okay. Okay, guys, I'll see you tomorrow. Bye-bye.